Hi guys, welcome to RTG Chemistry. Today we'll be looking at the diagram of an atom and we will be using the Bohr's model. So the Bohr's model is like this. Now, please keep in mind that the Bohr's model is not the only model. There are other models out there. But right now we're going to be using the Bohr's model, and this doesn't actually represent how an atom really looks like, but it gives you a rough understanding of how an atom is, and the properties of an atom. Okay, so in the Bohr's model we have the electron. Okay, the electron is the smallest particle. Well, it's not the smallest particle. It has an anti-particle called a positron, but that's beyond the scope of this video. Right now, we're just going to be looking at it from the basic perspective. In the basic perspective, there's only the smallest particle is the electron. Okay, and it's suspended on a cloud. These rings, these black rings with a blue glow around them, is a cloud of it's a cloud known as the electron levels, right? Or the energy levels, rather. Okay. Now, the energy levels, these electrons suspend within the energy levels. Okay, we'll talk more about the energy levels in detail much later. Then we have the nucleus. The nucleus is made up of two particles, namely the proton and the neutron. Okay, the proton is the positively charged particle, which is the opposite charge to the electron, which is the negatively charged particle, right? And the neutron is a neutral particle. It doesn't have any charge. Okay, so the positively charged proton attracts the negatively charged electron, right? Now you might be wondering, why doesn't it just crash into the nucleus because they attract each other? That's another discussion for another day. We'll look into that. It's more complicated for this particular video. So, these two particles make up the nucleus, okay? And the proton and the neutron are roughly the same size, right? And the proton is way bigger than the electron, right? And that's one thing you should keep in mind. Okay, so moving on. Now, if we're talking about the energy levels, which are also called shells, right? The energy levels are these rings that are included in this image. And there is the lower energy level, which is around here. There's the higher energy level, which is up here. Okay, and this being the higher energy level is the electron in these energy levels, because electrons ride energy levels. You never really find an electron, in the nucleus unless it crashes into the nucleus, which in that case will become a special situation known as electron capture. We will discuss that much later. Okay. But when the electron is around here, this is a high energy level. That means it has very high amount of energy when it's around in this upper area. But when it goes down and it loses energy, it drops into the low energy level. It means it has very low energy. And that means you have to keep putting energy into this electron to push it back into the higher energy level. Right? Okay, so moving on. Now, these things that you see right here are just different names of the energy levels, right? So the lowest energy level, which is K, okay, it's known as energy level 1. In fact, we use the numbers to represent them more often than we use the letters. So K, L, M, N, it goes up like that, then O, then the rest, right? But when it comes to K being the lowest energy level means it's the energy level that has the lowest energy, so to speak, right? And it's represented as 1. And then the next energy level up higher than that, L, is also represented as 2. Then it goes on like that. Then M being the higher energy level, then L is represented as 3, then N is represented as 4, and it goes on like that. But keep in mind that 1, 2, 3, 4 is the main way we label these energy levels to make things much easier. So this set of numbers that represent the energy levels are called principal quantum numbers, okay? And it stands, and the principal quantum number has the value n, or energy level, right? And it's equal to 1 or 2 or 3 or 4, as we spoke much earlier, okay? Moving on. So now we're looking at max number of electrons per shell. Okay, when you're thinking of max number of electrons per shell, you think about how much electrons can fit. Okay, the maximum of an amount of electrons, right? What's the maximum amount of electrons can fit within each energy level or each shell? Because remember, energy level is also called a shell. Okay, so around here, the amount of electrons that can fit around there would be different than the amount of electrons that can fit around there in their maximum amount. When I'm talking about the holding capacity of these shells, right? And there's a formula for that, 2n raised to the power 2, right? Now, how did we get this formula? We will talk about that when we start discussing, orbitals, but that's going to be sometime later in the same slide. Okay, now we're talking about 2n, right? If we substitute in the energy level 1, as we spoke about last time, remember energy level 1 or energy level k, but we mostly use energy level 1 to represent it, which is this energy level around here, right? That's energy level 1, right? So when it comes to energy level 1, the answer will be 2, because if we put 1 into n's position, right, as a principal quantum number, it will be 1 raised to the power 2, right, which is 1 times 2, which give you 2, and that you get 2 electrons. If you do that with 2, put in 2 in there, you get 8. You get 8 electrons. If you put in 3 in there, right, the calculation will give you 18 electrons. You get 18 electrons. And if you go in there and put in 4, you get 32. That's 32 electrons, as you can see. So all these are the maximum holding capacity each of these particular shells can hold. Okay, now if you wonder, okay, where are these electrons within the shells? Where the electrons are within subshells or sublevels. Okay, that means within these energy levels, these rings, you see there are there's another level called a sublevel or subshells inside these energy levels, right? And they have these sublevels, right, have specific symbols that goes with them, right, called S, P, D, and F. So they are about 4. Now there are more than that, but we'll not be talking about that right now. There are about 4, right? 4 of them. It's for 4 sublevels, per energy level. So this one has the potential to hold S, P, D, and F, but this one doesn't have it, but does have S, P, D. This one has S, P. This one has S, but they all have they each have one of these subshells or all of these subshells, right? So they either have one of these subshells or all of these subshells. If that's not very clear, I will keep explaining it. Okay, so now in this one, as I said before, this energy level 1, we have only S subshell inside, right? Or there can only be an S subshell within it, or sublevel, right? Within this one, there can only be S and P, right? Within the next one, there can only be S, P, and D, right? Okay, I think I made a mistake. It's supposed to be this anyway for this one, right? So just keep in mind that between this last subshell, we have S, P, D, and F. Okay, so we have all these subshells in here. In the third one, which is supposed to be this, I just made a mistake, it's supposed to be S, P, and D. In the second one, it's supposed to just be S and P. In the first one, it's supposed to be S. Now, what does this look like? Well, it looks like the more you increase, right, the more you get more subshells, more sublevels, right? And it also seems to me that the amount of sublevels, right, correspond to the number of energy level. So 1 has S, 2 has S and P, 3 has S, P, and D, 4 has S, P, and D, and F. So 4 sublevels for level 4, 3 sublevels for level 3, 2 sublevels for level 2, 1 sublevel for level 1, right? And you can see the table. Okay, you can see the table. We have S for 1, SP, SPD, and S, P, D, and F. So you can see it corresponds like that, right? And this is the nth, or the principal quantum number. Moving on. So now, if we're looking at some notes, okay, the first note we recall is that all sublevels must be filled before moving to the next sublevel within the shell. What does that mean? Okay, so that means once you have this sublevel, okay, right? You have to fill it up with electrons before you move on to the next sublevel within the shell. Okay, so let's use 4 for instance. If I have S, I have to fill up S before I move to P. I have to fill up P before I move to D. I have to fill up D before I move to F, right? Or if this is the first one, right? If I have S, I have to fill up S before I move to the next one, which is S around here in the next energy level, right? And I fill up one up before I move to P. That's the way it works. Okay, or then the next note will be the maximum sublevel must be filled within an energy level before moving to the higher energy level. That's just what I explained earlier. So you have to fill up this sublevel before you move to the higher energy level, right? So if I have to fill up S, I can just put one electron in S, then jump to energy level 2. No, if I'm in 1, I have to fill up S before I even jump to the next energy level, then fill up all these other sub-levels before I jump to the next energy level. They fill up on it just goes on like that, right? Keep that in mind. So now, if we were to zoom in, okay, into those energy levels, remember this is the black and this is the blue glow. The black, the blue glow, representing the energy levels. Remember the energy levels are the first order we're talking about, those clouds, those rings, right? So if you want to understand how these sub-levels are placed within the energy levels, this is a good diagram to show you how they are placed, okay? So first of all, we have, these particular keys to follow through or to make us understand how they are placed, all right? So in N, we have S. So we have to have the first energy level, which is S. Sorry, the sub-level, which is S, right? And because it's the nth place, we can only have 1. Since it's 1, you can only have 1. So we leave this entire one. That means only S can be in this, in this energy level. Now, go to the next one. We have 2. So we can have S and P, right? Then go to the next one, which is 3. We can have S, P, and D. 3, right? Then go to the next one. We can have S, P, D, and F. We can have all of them. Since it's 4, we can have all this. Sub-levels, okay? That's just a diagram to make you really understand how these things are positioned in these, energy levels, okay? So we're moving on now to the final, which is called orbitals, right? So now I'm trying to show you how the orbitals are placed within, okay? Within the energy levels. Now, what are orbitals? Well, orbitals are the last place whereby electrons are placed within the atom, right? So we have the energy level, then we have the sub-level, then we have the orbitals. The orbitals are the last place where the electrons are placed, and orbitals, of course, are found within sub-levels. And the sub-levels are found where? Within energy levels. So the orbitals are found within the sub-levels, S, P, D, and F. We can find orbitals within them, and that's the area that contains the electrons, right? That's the final stopping place for electrons. You get me? So keep that in mind. Okay, now the sub-levels within S, okay, are always going to be the same, right? They go up in odd numbers. We see what I'm talking about later, but first of all, this is how the sub-levels appear. For the S, okay, sub-levels, we're going to have an orbital, which is 1. So the S sub-level contains orbitals that are 1, right? They have 1 in value, right? The next sub-level, which is going to be the P, contains 3 orbitals. Okay, these are the orbitals, right? Just in case you don't know, right? And the next one that are 3, that is D, sub-level D contains 5 orbitals. And finally, the last F contains 7 orbitals. Now, what does this look like? Remember when I said that they go up in odd numbers? That's the way it is. There's 1, okay, there's 3, there is 5, and there is 7. So 1, 3, 5, 7. 1 orbital for S, 3 orbitals for P, 5 orbitals for D, and 7 orbitals for F. That's how they go up. They go up in odd numbers, right? And it has this really cool structure. Now, this is another cool trick. Each orbital can hold the maximum of 2 electrons. The maximum of 2 electrons. So you're going to fill up all the orbitals in this atom, right? Right? The maximum of 2 electrons will fill up each orbital, right? Now, if we're looking at the energy level 4, right? you can see we have all these orbitals here. That means it's if this one has 1 and 2, right, it can no longer take any other electron. This one has 1 and 2, it has to, when you fill up this one with 2 and you continue to fill up the rest of them, the maximum each of these orbitals can take is 2 electrons, right? So that's represented by this. Okay, so these are the electrons. This is the maximum, they all can take. So now if you're looking at this carefully, you realize something. If you count the electrons, you realize something, right? If each orbital can have 2 as a maximum, each orbital can have 2 as a maximum, and you go up in energy level, as well as, because if you go up in energy level, you also go up in sublevel. It's just the way it works, right? So this one has all, the sublevels, because it's the highest energy level in this diagram. It has energy level n, equal to 4, right? Because it has energy level 4, it's going to have all the sublevels, means it's going to also have, if you're going to fill up all the sublevels with electrons, if you're going to fill up all the sublevels with electrons, you're going to have the total of 32 electrons. You don't believe? Check this out. This electron total, right? So remember when I said we will get to why they have those numbers of 2n is equal to 2n squared, right? It's equal to either 2 for n is equal to 1, 8 for n is equal to 2, 18 for n equal to 3, right? And 32 for n is equal to 4. Remember when I told you we're going to find out in the orbitals, where this is where we find out why that's the case. The electron total, that means the amount of electrons total, if you add everything up within the sublevels, within the orbitals, within the sublevels, within the energy levels of the specific energy levels, we're going to come up with the total of 2 if we have n is equal to 1, because the electrons that are all inside the orbital all add up to 2, right? That's the point. So if we go into here, because we have 1 and we have 3 around here, we multiply 3, right? Which is the maximum is 4, right? We multiply 4 times 2, we get 8. Around here we have the maximum of how many orbitals? 1 plus 3, 4. 4 plus 5, 9, right? So 2 times 9 is 18, because we actually have 2 electrons per orbital. That's the point. And the same thing with 32, right? That's the reason why we have these numbers. That's the reason why we had the formula 2n squared, right? That's the reason. So keep that in mind. Okay, so now for the summary. First we have the electrons, then we have the electrons entering into the orbitals, they have the orbitals entering into sublevels, they have the sublevels entering into energy levels, and of course the energy levels are surrounding the atom. So keep that in mind. Thank you, and that's that for now. Bye.